und Musik. Ladies and gentlemen, please welcome your host, Cornelia Ertl.
Thank you very much. Thank you very much for announcing, and welcome back, everyone. Welcome back from the break. I hope all of you had the chance to maybe enjoy a good Viennese cup of coffee. I really hope that you're set and ready for this afternoon's program. Welcome, of course, also to all of our audience, online audience, watching us in front of the screens. So wherever in the world you're watching us, welcome one more time. Welcome to Green Tech Days Meet Future of Building 2024. I'm now very excited for our afternoon program. We are dealing with the first session and building materials in motion. It's a big topic, and we have several experts who we invited for you here today, and I'm very much looking forward to introduce the first one real soon. So in this session, we will explore the dynamic terrain of groundbreaking materials, innovative construction methods, and cutting-edge technologies that are fundamentally reshaping the construction industry. So we will now have 3 company representatives here on stage, each delivering a presentation of 10 minutes on the state-of-the-art technologies in their respective sectors. First, I would like to introduce the first speaker. She's going to be talking about renewable raw materials as the key to sustainable construction. Ladies and gentlemen, please welcome building materials expert at STRABAG AG, Winona Naomi Reddig. Welcome. The stage is yours.
Okay, it does not work the first step. I would like to welcome you, and I'm pleased to give you an insight into my work as a building material expert at STRABAG. My name is Winona, and in my current position I deal with the integration of renewable and ecological building materials. Our aim is to integrate sustainable and eco-friendly building materials into the construction process in order to realize long-term positive effects for the environment. It is not just about reducing our ecological impact, but also about creating buildings that meet today's requirement for energy efficiency, sustainability, and resource protection. I look forward to telling you more about how we are working to integrate renewable and sustainable building materials. STRABAG is currently focusing mainly on the production of important but CO2-intensive building materials such as concrete and asphalt. It is well known that the production of cement is associated with significant CO2 emissions, that this industry alone contributes 6 to 8% of global technogenic greenhouse gas emissions. With this in mind, we are aware of the challenges associated with the use of these materials. We are therefore working hard to minimize the environmental impact of our activities. Our efforts are focused on developing solutions that allow us to make our construction process more sustainable and reduce emissions with conventional building materials. At the same time, we are working on integrating green and sustainable building materials. These materials are characterized by a lower environmental impact and help to reduce the CO2 footprint of the construction sector. By developing and using eco-friendly building materials, we want to make a positive contribution to protecting the environment and combating climate change. As part of our research and development efforts into eco-friendly building materials, we have carried out full analysis of different potential raw materials. We have looked at which of these are available in our latitudes, are renewable, and ideally occur as a waste material. Our aim was to find materials that could replace conventional building materials without placing an extra burden on the environment. Yeah, in the process, we came across materials such as reed, hemp, and straw that are already in use. These natural materials are characterized by their environmental impact and can be used in construction without the need of chemicals. Straw, reed, and hemp can not only be used as a single materials, but also in combination with conventional building materials. They can even replace particular building materials on a one-to-one basis and therefore represent a sustainable alternative to conventional building materials. The building materials resulting from the raw materials are characterized by the fact that they are energy efficient, that they make energy efficient buildings possible and do not harm the health of the occupants. They are also characterized by a choice of materials and production conditions that also contribute environmental and climate protection. I would like to take a closer look at the different ecological raw materials I already mentioned and go into brief detail about their properties and areas of application. So, the first one is reed. Reed is a sweetgrass that's found in the wetlands around the world and grows up 4 meters high. It grows in banks, in ponds, in monocultures, and it cut once a year in the winter to maintain the areas. Harvesting takes place traditionally in the winter on frozen ice, which has the positive side effect that the fauna and flora of the reed ecosystem are affected as little as possible. So traditionally, reed can be used as roofing or as multi-laid reed isolation panels and as plaster base and clay construction, or as an impact sound or blow-in isolation. It does not absorb damp and therefore it rots very slowly. So the next one is hemp. Hemp is one of the plants with the longest cultivation tradition in Europe. It reaches a heat of up to 3 meters and a mass of 10 to 12 tons per hectare in a vegetation period of 120 days, of only 120 days. Hemp is a very easy plant to grow and can be cultivated without herbicides and insecticides. Thanks to its fast growth, it can be used as a paddock crop and leaves a soil weed-free and loose. Hemp can be used, for example, as an isolating material or sound absorber in various areas. The last I want to present is straw, and straw has been used as a building material for centuries, but sadly has been forgotten. In view of large volume and grain grown in our available land, there is enough straw available for use in construction. Straw is an every year renewable raw material and does not compete with the food production. None of the raw materials mentioned are in conflict with the food production. I think it is available locally, requires no extra production or energy input, and causes no extra environmental impact. Straw can be used in many different ways in the construction industry. For example, as a blow-in isolation, it's the easiest way, a sound-absorbing component, as fill-in for building straw bales, and even as a load-bearing structure made from building straw bales. That's a very cool thing. It's important to point out that sustainable building materials made from renewable raw materials are not the only solution for building projects. In fact, a balanced combination of different building materials is essential in order to optimize building quality. At this point, I would like to point out that many materials, such as conventional, not recyclable isolation, can and must be replaced on a one-to-one basis in many cases. Unfortunately, many of these alternatives have been forgotten since industrialization. However, through the introduction and target use of such building materials, we can make an important contribution to reducing the ecological impact of construction, among other things. The world is facing big challenges, such as the climate change, social inequalities, and the limited resources. The way we manage and build today will be critical in shaping the coming decades and the well-being of future generations. In view of these challenges, the optimal use of existing, preferably renewable and regional resources is becoming more and more important for the construction industry. Promoting sustainable use of materials and resources is of key importance. The aim is to develop and use only building materials that are recyclable or biodegradable. Ecological construction calls for initial investment, but leads to cost saving in the long term. This is where industry meets culture. Once a building has been completed, nobody asks what it costs, only what it's worth. Thank you.
Thank you so much. Winona, Naomi, Reddig, thank you so much. And the next presentation, I'm very much looking forward to that one because it's going to deal with modular construction with 3D building elements. And speaking of 3D, before I actually introduce you to the audience, I would like to draw your view to this thing over there. So it's a 3D concrete model which is here on stage, and it happens to be the logo of Advantage Austria. And our next speaker, I'm very sure about that, can tell us a little bit more about it. Please welcome Sales Director 3D Concrete Printing at Baumit GmbH. Here's Eduard Artner.
Okay. A warm welcome to all of you. Thanks for the possibility to do a short presentation. Just to start at the very beginning, this little piece of concrete, it takes a printing time of about 10 to 12 minutes, and then it's done. And this is exactly the topic which I would like to start with. What is our mission? That's a very important point. Where do we head to? What do we want to achieve? And it's pretty easy. It's always the topic modular building. The second one is if we identify a project where we can use this, we always have to find a weight-reduced opportunity. That means all these parts which we produce have about 35 to 40% less on material, and with the same properties compared to standard technology. It's fast and easy, and just as an add-on, it's the butter of the bread, more or less. You can really choose in terms of design whatever you like. But that's the mission. Let's hop through a lot of projects. That's a very easy one. It's just a playground. It's a garden fence. Yeah? But at the end of the day, it's a type of module, and this fence is about 10 meters in length, and the time which you need to build it up is around 4 hours, and then it's done. The next one, this is, has been done in Innsbruck at the university. It was a project together with Habau, and the topic was simply, let's try to find an exotic design, but always it needs to be a building module, and it needs to be weight reduced. In this case, if you would like to go this with a standard technology, forget it, it's too expensive and you simply wouldn't manage it. In that case, you just need about 20% of the material compared to a standard technology. But now let's go to the real world. We intend simply to find real-life applications where you guys really benefit from it. And this is a project in Germany, not an easy market in terms of rules and regulations, as most of you guys know here. And it is the entrance of a parking lot, about 170 square meters in dimension. It's a ceiling. And this is the first draft. How did we do it? It's a very simple idea. It's like in the 60s, you avoid volume by implementing small blocks, which, as you see on the right-hand side, where you have those hollow structures, and you simply place material where you need it and you leave it where you don't need it. In that case, this is the construction site itself. You combine simply good new technology with old methods. And the point is, it's reinforced the standard way. You have all those parts here to generate the hollow parts, and at the end of the day, you end up with about 40% less on material needed for this one. let's go one step further. This is how it looks like in reality, and we are really happy to announce that we got the German Architectural Award end of last year for this building, mainly because of the environmental and sustainability issues. But we can play this a little bit bigger. Just for those who are in the building industry, we have all the testings which are necessary to build it. That means all the heating tests, all the tests which you need to build it. On the right-hand side, you see this beam from before. It is tested till it breaks. It's like a banana, but it still didn't break. And this is now the biggest one, which we realized about half a year ago. That's a building in Bludenz, in Vorarlberg, in Austria. This one is 700 square meters in size. And at the end of the day, you save easily about 30 to 40% on steel and concrete as well. And the simple formula is, if you don't need such a lot of material, you also save CO2, and that's more or less a no-brainer, and it looks simply great. Where do we stand with this projects? We have now about 2 and 3 new projects ongoing, all in a size between 500 and 800 square meters. We are really developing further on this type of construction method. This one, now let's jump from the big one back to the small one. This is simply an example which we built up directly at our home base in Austria. What does it stand for? Very simply, that's the same type of ceiling which you have seen before. It's simply an example what you can do with this type of technology. What is the possibilities of modular building. You see those columns here. They are, at the end of the day, they are cut in 3 pieces. You simply stack one on top of the other. And you can do it with a normal design. You can play around as whatever you like. Printing time of such a piece, 10 minutes, something like this. At the background, you see here these wall parts. They are about 3 times 2.5 times 1.5 meters. Printing times about 1 hour, 20 minutes, roughly like this. And you print your modules, you bring them to the construction site, you set them up, and you went home again, and everything is easy and fine. And in this case, they are fully filled with concrete and they are reinforced, but you can also do them in a type of hollow construction so that you end up with the same material savings as you have seen beforehand. And that's a very simple one. You can order these type of parts, 1,500 or whatever, and you place them directly at the construction site. You avoid all your wood to cut it, to tear it apart, to bring them out. So it's pretty simple and easy, and you avoid a lot of complexity in the building process itself. Now we have a project in Germany going on where they need about 1,500 of those pieces. Yeah? Yep, at the end of the day, pretty simply, as I'm a technician, a little bit of a technical information. It's a 2-component system for those who know it. The compression strength is around 35 megapascal and 9 is the tensile strength. What's very important for those guys who are in the concrete business, it is a start and stop function, and the material sits about 1 hour liquid. That means you can easily incorporate it or build it up in a precast factory, because you do not have any hurry to clean or whatever, because you can wait 1 hour till the next step. Yep, and this is a quick movie without the sound. Maybe you can play it in, otherwise I can comment it. That's simply, those are the parts of the garden wall. They're about 2.5 meters, up to 3 meters in This is one. Here you see here you see how they printed. This guy is standing in front of you and telling you the same what I have said the previous 2 minutes. Important is that you can print angles up to 60 degrees. That means you are very free in printing a form. That's the start-stop stuff. Very important because you do not need to continue the same path. You can stop, you can start, and therefore you have a lot of different geometries which you can access. And this is pretty impressive. It's playing around. You can really steer the system that you play in a parallel manner. And if you want to have plane surface or whatever, always combine good old stuff with good new one. You can smoothen it, you can reinforce it, you can sandblast it, you can paint it, whatever you like. It's always combine all these methods which are available to get at the end of the day the best final result. And this is how our material looks like. This is Martin. He's designing the print. And this is our team. Whenever you have an idea, a project, whatever, just give us a call. We are happy to serve you to fulfill your dreams. Thanks a lot.
Thank you very much, Eduard Artner. I'll take this one. And if people have any questions or want to get in touch with you, how is that possible? Are you going to be here all day today, or can people reach out to you?
Just give me a call. No, very easily. There's downstairs the info booth, and tell those guys that you want to talk with me, and they can reach me. That's the easiest way.
Perfect.
Okay?
So just go ahead and reach out. Thank you very much, Eduard Artner. And our next presentation will be about technologies for a sustainable road construction industry. And I'm very much looking forward to introducing the next speaker. Please welcome the CEO at Q-Point GmbH. Here's Thomas Leopoldseder.
Good afternoon from my side. Let's change the material. We have seen straw, we have seen concrete. Now let's go to asphalt. Why asphalt? And first of all, a short introduction of our company. We are a software company and focusing on digital solutions to support the process in the asphalt industry and to support all stakeholders in this area. Why asphalt? Asphalt is a material which is common around the world, and if we are thinking about electric cars or anything else, rollers, bikes, we will need asphalt also in future. And if we look on the production of asphalt, you see here some figures. In the European Union, we are producing 212 million tons a year of asphalt. And if we go a little bit further, then we have around 300 million tons of asphalt. And you see here a statistic about asphalted roads in the world. You see here USA and China have the longest roads of asphalt in the world, but also the European countries have a long network of asphalted road. And that means if we are not building new asphalt roads, we have to maintain them, we have to repair them. So asphalt is also a product not only of the current situation, it's also a product in the future. If we look on the CO2 emissions of the asphalt production process, we see that most of the emissions will be done to produce the raw material, which is bitumen in most cases, and on the other side, it's production of the asphalt in the asphalt plants, and then we have some several other aspects, transport of raw material, transport of asphalt, and at the end, the laying and installation of asphalt. So we have to concentrate on this first and on this third part in the whole value chain. But producing is a technical job, but it's also necessary to know what you have to produce, and this is exactly what we are doing here. We help the asphalt plants to find out in a better way what they have to produce to optimize their production program and many other things. Another thing is shortened construction time. You see here the result of some research that if a car is driving very low, and I speak with 30 kilometers per hour or below, then you see the CO2 emission is rising very fast. And here also with 100 kilometers per hour, also the CO2 emissions are rising very fast. So the optimum way of traffic is between 30 kilometers per hour and 100 kilometers per hour. But we know if we have a construction on a motor highway, then we have the stop-and-go traffic. And this stop-and-go traffic causes that we reduce the speed on the motor highway, and then it costs a lot of CO2 emissions, which can be avoided if we can speed up the constructions. So how we can do it? But the problem is that asphalt is a material that is just in time. You have to produce it, you can store it a little bit on the asphalt plant, then you have to deliver it, and then you have to use it on the construction site. You cannot store it on the construction site. The second point is that a continuous pavement is important. That means that this machine, we call it paver, is continuously working so that the temperature of the asphalt is always the same, the asphalt which is laying on the road, and also the new asphalt which is coming from the paver on the road. And the second one, the third point, is that asphalt needs a certain temperature to be installed. So if it's getting too cold, the quality of the road is getting bad, and that's also a very large problem. Okay, what are the main things we have to consider if we look on the asphalt industry? We have a lot of requirements of stakeholders. These are the government regulations, financial institutes, but also the society, which expect that we do a lot of things to make it more sustainable. We have to use more recycling asphalt to bring that material from the road in the production process. We have to reduce the batch changes, which means when I produce different types of asphalt, it's very energy costing. It costs a lot of energy if you change the type of asphalt in the production. So a continuous production with the same recipe would be the best way, but you have to do that. Then we have to do a lot of documentation for maintenance for the next 10, 20 years. We have to increase the lifetime, so we have to increase the quality of the roads, minimize emissions, reduce transports, and shorten construction times, as I mentioned. How can we do that? Our idea is to support the people along the whole value chain with an integrated digital solution, starting from the planning of a project, the ordering of asphalt process, the production process to optimize the production, then also integrating the truck driver for the delivery process. Then we equip the machines with sensors and with other things to optimize and monitor the pavement and the installation of the asphalt. And you see the tools that we are using is the mobile phone, the tablet, a smartwatch, dashboards to give the information to the people that they need to optimize their processes. Here a short video. You see here a paver. We equip this paver with different sensors to measure the temperature, because it's very important to know the temperature during the paving process. On the right side, you see the rollers making a road. Also, these rollers are equipped with sensors measuring the temperature, measuring also the passes during the construction process. All these machines are linked together, and at the end of the day, we get a very good documentation, and we get the right information for the people on the construction site to do a good job, to have a high-quality road, a long-lasting quality road, and also with short construction time. Another example is to reduce the temperature of the asphalt in the production. Here you see a very short example. if you reduce the temperature of asphalt by 30 degrees, which is normal, and we have 200 million tons of asphalt a year in Europe, then you save around 382 million tons of CO2, because the production, when you remember, is one of the most consuming CO2 processes in that process. In Germany, it's mandatory to use low-temperature asphalt since 2025, but I know that there are a lot of companies and countries which are not thinking about that, but it will bring a very high effect on the CO2. How can you produce low-temperature asphalt? You need the production technologies, but these technologies exist. You need exactly the transport and the way of the asphalt to the construction site, because when the temperature is too low, then you cannot bring it on the road. So you need information about the logistic chain. You need information during the installation procedure. Also, we provide information about the energy consumption of the asphalt plant and the whole process, which helps to analyze and optimize. At the end, you have a digital information database along the whole value chain. You have delivery information, you have temperature information, you have installation information, and this is the documentation which you need in 10 years or 15 years to maintain and repair the road again. So what are the main advantages? To summarize that, we can reduce the usage of resources. We help the people to do better decisions. We support the people on the road or on the construction. The process will be more efficient, and I tried to explain what are the benefits are. We can also support this low temperature asphalt, which is very important for the CO2 emissions in that process, and we collect a lot of information. We are working for the future of these children. Thank you for your attention.
Thank you very much, Thomas Leopoldseder. Thank you very much for being with us today. And please, to all of you who want to get in touch, just go ahead and reach out later on in the break.